our objective for today, I can simplify exponential expressions using the division properties of exponents. Read together. 1, 2, 3. I can simplify exponential expressions, division properties of exponents. Okay. So if you notice, we're still on division. Today we're going to finish with division. And in your FAIR model, what shall you write? Exponential expressions, right? And I asked you to write the definition by yourself, one example, one non-example, and a hashtag. Share with your neighbors, see what they got on that. All right, so you know what to do with that, right? You fill it out, and it should look something like this. Yes? Okay, good. So you'll finish that by yourself. Steps. You don't have to copy the steps. You already have them. But look at the step. It says, number 1, identify the exponential expression as a quotient of powers or power of quotients. From there, use the appropriate property to compute and simplify. So yesterday we covered quotient of powers property. Today we're covering power of quotients. So let me review, a quick review on quotient of powers. Quotient of powers, remember that we started with, I think I did 3 to the 6th and 3 to the 4th. Remember that? Yes? And we agreed that if it was the same base, tell your neighbor what happens to the exponents. So therefore we get, are we there? And then from there I said you can do the next step, which is simplify, and that gives us 9. Yes? And then we did some examples here in class. Yes? From there, and then we did one of those, and so on and so forth. So that brings us to this one. Copy that. Power of quotients property. You can copy that and then your FAIR model, you have space. Power of quotients property. Example Q. Okay, so here we go. I'm going to go ahead and do the example. I want you to pay attention. I'm going to have you guys share with one another. From there, we're going to do the definition. So write your utensils down, look up to the screen. Write your utensils down, look up to the screen. Y'all ready? Yes? Okay, here we go. So before I begin, yesterday we said we began with quotient of powers, which looks something like this. Is that correct? However, today we're doing what? Power of quotients. Look how much it changes. I'm going to give you a second one. Okay, talk about you never let them know what's going on with the power of quotients property. All right, so just to clarify, did it matter if they had the same base to use the power of quotients property to get to here? No. So therefore, look up before you copy. At this point, can I simplify this? Yes, using which property? quotient of power property. So let's see, that gives me what, everyone? 3 to the 10th. Can I simplify this anymore? No, that stays the same because they're not the same base. All right, copy that, please. Underneath that, I want you to write an asterisk, a heart, and then we'll come up with a definition. Copy that. While the rest finished copying, do me a favor and go back into your notes, and I want you to look for power of powers property when we covered the multiplications, right? I want you to read the definition for powers of powers property by yourself. Power of powers property. Okay? So now, go back to what we did right now and talk it over to your neighbor. Let them know what would be a definition for this property, power of quotients property. All right, let's see. Isaac, get us started. The power of quotients property, what is when, that's someone, Hunter, when you raise, hold on, before you say exponential expression, we know we're dealing with exponential expressions, right? The power of quotients property is when you raise, however, this has a particular name. Yeah, it is a fraction, but it has a particular name now that we have, now that we're dealing with exponential expressions. What is the name of this, Hunter? Who sees it? Yes. Not the property, but this is called what? Quotient of powers. We use the quotient of powers property to do the next step. So what is this called, everyone? Quotient of powers. So let's see, in our definition I read, the power of quotients property is when you raise what? Quotient of powers pass it to someone, Hunter. When you raise quotient of powers to what? Couple more, guys. What are these called? To another exponent. There you go. Another exponent. Comma. Pass someone, Brody. Fatima. Finish it off. It says the power of quotients property is when you raise quotient of powers to another exponent, comma, we what? Okay, so now we're here and we go to here. What's happening from here to here? Close. Devin. We multiply the exponents. 10q. Okay, let's double check to make sure that we're understanding that. The power of quotients property, which is what we did from here to here, is when you raise a quotient of powers. Here's a quotient of power. We're raising it to another exponent. What happens? We multiply the exponents. What is 6 times 5? 30. What is 4 times 5? 20. And at the end, if we can simplify, we use the quotient of powers property. What happens there? Now we subtract. So now this is what's going to happen, guys. As we continue using more properties for exponents, your noodle is going to start playing little tricks on you. Because you're going to see like, okay, do I subtract? Do I multiply? Do I add? So now that we have different things going on. So just go one step at a time, rewrite it, make sure you're using the appropriate property. Okay? So let's start slow. Ready? Start with this one. Example 4a. You can fit it underneath that, and then after that one, we're going to do the other ones in the back of the paper. So copy this one, example 4a, and I'll give you a head start for this one, 20 seconds, so that you can do that one by yourself. Simplify, 4/7 raised to the second power. Copy that and go. All right, so look up to the screen. What I'm about to do is incorrect. Can you hear what I just said? So check this out, because some people see that this number looks kind of like that and they do this. That is incorrect. Why? What did they forget to do? They forgot to do the first thing I asked you guys to do. Anytime you see a number or a variable without an exponent, we put a what? A 1 and a 1. So here we go. So now that we have a quotient of powers here, now we need to raise it to another power. What happens to the exponent? We multiply. That's 4 to the second over 7 to the second. Can I simplify one more step? Very good, yes. What is 4 to the second? 16. What is 7 to the second? 49. Copy that, and if you didn't go the extra step, and do this next one by yourself. Example 4q. Parentheses, let's do 1/2. Close parentheses, raise that to the third power. Go. Okay, what'd you get for this one, Julian?
I got 1/8.
Hands, if you got 1/8, that is correct. Put an exponent of 1 here and here. Distribute. This is 1 to the third, and this is 2 to the third. 1 to the third is 1 times 1 times 1. What is 1 times 1 times 1? 1. 2 times 2 times 2, that is 8. You got this? All right, let's crank it up a notch, yes? Example 2b. Turn your paper over. You copy that one in the back. Example 2b reads, simplify. Let me zoom in for those that can't see from back there. There it is. Simplify. In parentheses, we have 3b squared over EF. Close parentheses, raised to the 4th power. I'll give you about 30 seconds to see if you can do that by yourself. Remember, go one step at a time. Start with the numerator first, then go to the denominator. See if you can simplify the next step. Copy and go. All right, here goes the process. What is the first thing to do? Put a 1 on anything that does not have an exponent. Next, I said, go one step at a time. Start with the numerator. Distribute, distribute. We get what? 3 to the 4th, d to the 8th. Next, denominator. E to the 4th, f to the 4th. Hands if you got it to right there. Okay, next, I said simplify when you can. Can we simplify 3 to the 4th? 3 times 3 times 3 times 3. What is 3 times 3? What is 3 times 3? What is 9 times 9? 81. Question. Is D the same base as E? As F? Is E and F the same base? Everything else stays the same, so it's D to the 8th, E to the 4th, and F to the 4th. Hands, have you got that? Okay. We got this, yes? All right. Let's crank it up a notch, yeah? Copy this one. Example 4C. Let's zoom in. Simplify. Now we got a big parentheses, and then on the numerator we got 2x cubed. In the denominator we got parentheses x plus y, close parentheses cubed. And then outside of the big parentheses we have squared. Now check this out. Look up, please. I want you to first simplify the denominator. Write it here. Bring the numerator over. And then at the end you're going to distribute the big exponent inside. Everybody understand? Okay. Do that by yourself. Example 4C. I foresee you guys getting it right. No? Nothing? All right, let's see. Here goes step by step. What did I say to do first? Okay, the denominator. But before that, I'm going to put ones on everything, and I'm going to start with the denominator. I distribute, and I end up in the denominator with x cubed, y cubed. Is that correct? I don't do anything to the numerator. I bring that over, 2 to the first, x to the third, and I said at the end, then we distribute that exponent from the outside. So from there, I'm going to start with the numerator first. Distribute, I get 2 to the second, x to the 6th. So far so good. Denominator becomes x to the 6th, y to the 6th. So far so good. All right, can I simplify any more? Yes, this becomes 2 times 2, which is 4. Question, is x to the 6th the same base as x? Yes. So what happens to the exponents? They subtract, becomes x to the 0. Let me just show it, x to the 0. What is x to the 0? A giant 1. So what is 1 times 4? 4. So do we need to write the 1? No. So what's the only thing that's by itself that has no other partners or bases? Y to the 6th. Where is it at? In the denominator. It stays in the denominator. And we're done. Hands if you got that. Okay, let's do another one. Example. I'm going to back it up right here. Example 4 mega Q. Do this one by yourself to see what you get. Let's do parentheses or big parentheses. You're going to do a fraction bar. In the numerator, you're going to open up another parentheses. You're going to write 3ab squared. Close the little parentheses. Put a little power of 2 outside. In the denominator, you're going to write AB, close parentheses, and all that to the second power. Very similar to the one we just did. On this one, you start with the numerator. Distribute that exponent in the numerator, rewrite the whole thing, and then at the end, distribute the 2. Ready? Go. Copy that and go. All right, let's see. If we get it right, we're done. If not, we do a couple more. How about Hunter? What'd you get? 81. A to the 2nd. And B to the 6th. Hands, have you got that? That is correct. Okay, before we leave, though, let me just get to this part. Negative exponents. Look up, please. Now, in the past, I've been letting you leave the negatives as negatives, right? Check this out really quick. 3 to the 4th over 3 to the 6th. This is 3 times 3 times 3 times 3. This is 3 times 3 times 3 times 3 times 3 times 3. So watch. 1, 1, 1, 1. What's left in the numerator? What is 1 times 1 times 1 times 1? 1. Oh, sorry, this is like this. What's left on the denominator? 1 times 1 times 1 times 1, 3 times 3, which is 3 to the second. Do you agree with that? However, if we use the rule, what happens to the exponents? We subtract, right? So this is what? 3 to the negative second. So what are we saying? That this is this, but it's also this. That means that this becomes 1 over 3 to the second. Does everybody see the reciprocal here? Yes? So what if I have x to the negative 3? What does that become? 1 over x to the positive 3. And what if I have something like this? 1 over y to the negative 2. What is the reciprocal? Y to the second over 1. So then it goes to the opposite direction, right? All right, your home play for tonight is over here. Play sheet. Home play is play sheet 7.4. Only do numbers 1 through 20. Good one, guys. Enjoy your home play. See you guys tomorrow. Bye.